stand still. Close your eyes. Feel the ground beneath you. Now tell me, is it moving? For most of human history, the answer was obvious. Of course not. The earth was still. The heavens moved. The sun rose, crossed the sky, and set. The stars wheeled overhead every night without fail. Everything you could see, everything you could feel, confirmed it. The earth was the center of everything. And for 2,000 years, we were certain. This is a story from a time before we knew. Around 350 BC, a philosopher named Aristotle gave the universe a shape. At the center, Earth. Motionless, heavy, fixed. Around it, a series of transparent crystal spheres, each one nested inside the next. The moon on the nearest. Then Mercury, Venus, the Sun, Mars, Jupiter, Saturn. And beyond them all, the sphere of the fixed stars, rotating in eternal perfect circles. It was elegant. It was complete. It matched everything the naked eye could observe. And it made philosophical sense. The heavens were perfect. Perfect things move in perfect shapes. Circles. Always circles. But the sky held a problem. The planets did not always move the same direction. Mars, Jupiter, Saturn, every so often they would slow, stop, appeared to drift backward across the stars for weeks, then reverse again. This was not what perfect spheres should do. And no one had a good answer. Not yet. Around 150 AD, an Egyptian Roman astronomer named Claudius Ptolemy had a solution. If the planets couldn't move in simple circles, he would give them more circles. Each planet moved in a small circle called an epicycle. That epicycle itself moved along a larger circle around the Earth called a deferent. Circles riding circles. And it was geometrically intricate. It was mathematically demanding. And it worked, at least on paper. Ptolemy's system could predict where planets would appear in the sky with reasonable accuracy. His book, the Almagest, became the definitive guide to the cosmos for the next 1,400 years. 1,400 years. Generation after generation built their understanding of the cosmos on Ptolemy's foundation. It was taught as truth. It was protected as truth. And the more complex and precise its calculations became, the more credible it seemed. A system that hard to build, that carefully maintained. Surely it must be right. In the early 16th century, a Polish church canon named Nicolaus Copernicus was dissatisfied. Not with religion, not with Aristotle, with the math. Ptolemy's system worked, but it required constant patching. New epicycles added to fix old inconsistencies. So he tried something radical. He put the sun at the center. He worked on his theory for decades, and he hesitated to publish. Not, as legend suggests, because he feared the church above all else, but because he knew his system was not yet perfect. He still needed circular orbits. He still needed some epicycles. He was right about the big idea. He was not yet right about all the details. His book, De Revolutionibus, was published in 1543. The year he died. The world barely noticed. In 1609, an Italian physicist named Galilei turned a newly improved telescope toward the sky. On the night of January 7th, 1610, he noticed something near Jupiter. 4 small points of light. The next night they had moved. Night after night he tracked them. They circled Jupiter, not Earth. Here was the proof no one expected. Not everything in the cosmos orbits the Earth. The foundation of 2,000 years of certainty had a crack in it. He published his findings in March 1610. The Sidereus Nuncius, the Starry messenger. It caused a sensation. But Galileo did not stop there. He found that Venus showed a full range of phases, only possible if Venus orbited the Sun, not the Earth. Evidence was accumulating, and powerful institutions were beginning to take notice. In 1616, the Church issued its warning. Heliocentrism was declared scientifically indefensible and contrary to Scripture. Galileo was instructed not to hold or defend the Copernican view. He complied. For a while. In 1632, he published the dialogue concerning the 2 chief world systems. One character, the defender of the old model, was named simply Tio. Some believe the Pope recognized himself in that name. The book was banned within months. In 1633, Galileo stood before the Inquisition, charged with suspected heresy. He was 69 years old. His eyesight was failing. He had spent his life looking at the sky and telling people what he saw. He recanted. He stated, formally and on record, that the Earth does not move. He was sentenced to house arrest for the remainder of his life. He died in 1642, still under custody. Still right. Science did not stop. Johannes Kepler demonstrated that planetary orbits are not circles. They are ellipses. That single correction solved the mathematical problems Copernicus couldn't resolve. In 1687, Isaac Newton published his law of universal gravitation, explaining not just that planets move, but why. The geocentric model had no answer for that. It never did. In 1838, a German astronomer named Friedrich Bessel accomplished something that had eluded scientists for centuries. He measured stellar parallax, the tiny apparent shift of a nearby star as the Earth moves through its orbit. It was the final observational proof. The Earth moves. It was always moving. In 1992, the Vatican issued a formal statement. Galileo had been right. It took 359 years. But perhaps that is not the most important part of this story. Geocentric belief was not born from stupidity. It was born from observation, from logic, from the best tools available, and from the very human need to make sense of what we see. For 2,000 years, it was the most reasonable conclusion a reasonable person could reach. The sky still looks the same as it did to Aristotle. The sun still rises and sets. Standing still, you still cannot feel the earth move. Certainty is built from everything we have. Every tool, every observation, every consensus, and sometimes everything we have is not enough. There is always a moment. Before we knew. This is before we knew.